Uh, Hello all. Uh, this is Niranjan Phadnaviss. I am a senior software engineer working in VMware by Broadcom. I am here today. I'm here to give a small talk on the topic socket communication in C++ made simple. So the target audience for this talk are novices or beginners, someone who has started working on in C++ and is relatively new to sockets. So from my experience, if you're a novice and not extensively working on sockets like every day, and it will be difficult to remember the concepts. Uh, you will easily read it from any website, understand it completely, even try out a simple C++ program from that site. But if you don't start working on it, eventually you forget the concepts eventually. There are dozens of websites which explain socket programming, but my attempt here is to explain in such a way that you can understand and remember the concepts. Therefore, for brevity, I will be skipping those parts which you can easily get from Google. Finally, I'll be available on the Discord channel for any doubts. Please note down your doubts you get while during the talk. Now let us see the agenda. Socket communication is important because it allows different computers or devices to talk to each other. It is the technology that is behind. It is the technology behind everyday activities like browsing the web, sending emails, and so on, so on. So the socket communication is a vast topic, basically, but it's a must know. Every C++ programmer or any programmer must know socket communication. So but since this is a short talk, I have kept the agenda as concise as possible. So, uh, what is socket communication? Socket communication is a way of connecting two processes on a network, or connecting two processes basically to communicate with each other. So, okay, so one socket listens on a particular port at an IP address, and while the other socket reaches out uh, to the server socket to form a connection. This is a client socket, okay, and its socket communication is just like a phone call between two devices. Just like you dial a number to connect with someone, a computer uses a socket to connect with another device to talk to that device. So from the image, of course, there is an AI generated image. We can see that these devices are connected to sockets, and they are communicating via the internet. Sorry. Now let us see the types of sockets. Okay. So we all know that there are two types of. We know that TCP and we all know about TCP and UDP. And so TCP is connection based protocol. UDP is connection less protocol. TCP has flow control, error control, accuracy, and hence it is more reliable. And also because of these added features, it has an added overhead. But UDP, since it's a connectionless protocol, it's fast but not as reliable. So we can say that TCP communication is like a phone call, which stays open, and both sides can talk back and forth. But a UDP is just like sender sending a text. So these are the two. So this is about TCP and UDP. And so similarly for TCP communication, we have TCP sockets, and for UDP communication, we have UDP sockets. And what is sock stream and sock datagram? So these are the keywords. And so when we create a socket using, I'll come to that here in a while. So so first I'll explain. So in C++, socket program is typically done using system libraries, as the C++ standard library does not include built-in support for sockets. So we use the same socket APIs, which is used by the even while programming sockets with C. And uh, in this API, we have a system called socket. And one of the argument uh, to be provided to the system call is the type of socket, that is sock stream. These are the enums and the sock datagram. So in while coding, we write it as sock dgram. So another argument that is provided is the address type, that is AF INET, that is for internet, uh, and this is for inter-machine communication. And AF local or AF Unix for Unix based machines. This is the address type, and this is for inter-process communication. So communication within the same machine. So for AF INET, we need IP address and port, and for AF Unix, we need is communicated via a file. Now let us see the classification of sockets that I have done. We have sock stream for TCP, sock dgram for UDP, for the address type of AF INET. For sock stream, we have a typical use cases are web browser, email clients, and FTPs. For sock stream and AF local address type, it can be used for reliable communication between processes within the same machine. For datagram, UDP, over the internet, we have voice over IP, gaming, and video streaming. And for local machine communication, it can be a typical use case is logging to a central logger. Now, I will explain a typical workflow in during socket communication. On the right, I have TCP. On the left, I have UDP. In TCP communication, the server socket creates a socket using the socket system call. It binds to an IP address and port, and it listens on a particular listens on that IP address and port for connections from client. Client calls a connect system call to connect to that server socket, and the server accepts the connection. Here, please note, please remember here that when the server accepts a connection from the client, it creates a new socket on which they can talk to each other. So there is a new socket that is created for this particular client. Okay, so this is the TCP side of this is the TCP socket process. On the left, we have the UDP. Here, the bind the server again binds to IP address and port, but uh, it does not listen and accept. Just the client connects to that server or socket, and they start connecting, they start communicating with each other. Okay, so I'll give you a moment to pause and absorb uh, whatever I have explained till now. Again, please note down all these doubts. I'll be clearing them. So next slide. So these are the common socket APIs, commonly used socket APIs. I have listed them down here. So on the so each for each the purpose and the header where it is found, I have listed them down here. So you will find all the details like what are the arguments, what are the return values for these APIs on the man page. Going next. So multi-threading and pooling. So when a TCP socket accepts a connection, if you remember, I just explained. So it creates a new socket for that client on which they further talk. Okay. So the first thing that comes to our mind for handling this independent communication is multi-threading. But if the number of clients increase, then it does not make sense to have as many threads as client. It is not. It is totally inefficient. So here comes the concept of a polar. So polars are tools which are used in socket communication to efficiently manage uh, multiple connections at once. Okay, so the polar keeps an eye on multiple sockets simultaneously. So when a socket has data to send or receive, the polar notices this and alerts the program. The program handles and processes the data for that specific socket. And after handling, the polar again goes back to monitoring. So see the efficiency. See the efficiency that is better than multi-threading. Okay. So in multi-threading, it can lead to excessive context switching and resource use. And so using a polar makes the system more scalable and performant for high concurrency scenarios. So coming to the last part of the presentation. So I believe that giving an analogy makes it easier to understand any concept. So if you relate theory to something in practical life, uh, it gets easily registered in your mind. So I will be explaining the TCP socket communication mainly with an analogy. So give me a moment. Sorry. So what we see here is a large hotel which has different sections like restaurant, dance floor, just like a typical restaurant, large hotel like coffee lounge and so on. So the man in uh, white man in white shirt is the host and who is listening. So okay, now he is a host who is listening on the physical address of the hotel. That is, the hotel has some physical address, and he is standing in front of the restaurant for the guests. Same as TCP server listening on an IP address, and we can say the port is the restaurant. So the port address can be different for coffee lounge, dance floor, etc. So our host, that is the TCP server, is listening on physical address and the restaurant port. Okay. So when a guest arrives at the restaurant, we can say he's a client. So when the guest arrives, the client arrives, the host accepts the connection, accepts the guest, and assigns him to a table by giving a table number. Okay. So here the table is the new socket created, and the table number is the socket descriptor of the new socket, which is an integer. Now, thereafter, the all the interaction between the guest, interaction of the guest happens at the table, and the host is not involved in this. So, till now, we have covered the socket APIs like socket, bind, accept, listen, and connect here. Okay. So, can anyone guess who is the what the security guard here signifies? You can put it on chat. Uh, yeah. So this it it signifies a firewall. So the guard may guard. What are the functions of a guard? So so the guard may deny entry to certain people based on the behavior or the that is a malicious traffic, uh, where they come from, the IP address. And suppose the restaurant has specific rules that only people with reservations are allowed. That is, so the guard will stop anyone trying to enter without a reservation. And suppose there is a malicious API or a known troublemaker, then who has caused problems in the past, then the guard or the firewall will block him. So so there can be another so many other functions that a guard can guard or a firewall can perform. Okay. So now coming to the multi-threading analogy. So if the waiter, if the restaurant hired one waiter per customer, then things could get so complicated as when more customers arrive and the staff would get overwhelmed. So instead, the restaurant uses a scheduling system, scheduling system or a polar. Just like we see in a typical restaurant, we have one person who is managing the waiters. Okay, so this we can relate it to a polar. So waiters and this in this scheduling system or the polar, so the waiters attend only to those customers who are ready to order or need any service. Similar to uh, when a socket is ready to read or write. So this ensures the efficiency of the restaurant and also avoids overcrowding or over hiring people. Okay, hiring the waiters. So, okay, so there are so many other analogies that I can relate, but I will leave it to the audience to use their creativity and understanding of this topic to relate to concepts like, say, Unix DOM communication, Unix DOM address types. How would you relate socket shutdown and socket close within the same framework? You can submit them in the channel, Discord channel later. So I took this example as these are very common scenarios in our lives. Everyone goes to hotels. So it may not match perfectly case to case, but I think it is good enough for you to relate. Uh, so hopefully next time you see a restaurant, you can relate to socket communication. Yeah, I know it sounds a little geeky. Yeah, but yeah, that's all I had. That's all I have. Thank you. Uh, I need